Chapter 6, Section 3, Solving Systems Using Elimination, Part 1. The elimination method. In the elimination method, you use the addition or subtraction property of equality to add or subtract equations in order to eliminate a variable in the system. So we've talked about so far, before this lesson, we've had two ways to solve systems of equations. We could either graph them, and then we could find the intersection point, or we could use substitution. Now we're talking about the elimination method. The elimination method is kind of similar to the substitution method for the second part, but the first part of the elimination method, you're going to take the full equations and you're going to either add or subtract them. And when you add or subtract them, what you want to happen is you want one of the variables, either x or y, to be eliminated or to add or subtract t equals 0 so that you can solve for one variable. And then just like in substitution, you're going to take that value and you're going to plug it back in to one of the equations to solve for the other variable. So if you solve for x in the first equation, you're going to plug in that number for x and solve for y, just like we did in substitution. Let's do a couple of examples of this. I think the words are kind of maybe a little bit hard to understand because we've never done anything like this before, but I'll show you some examples that you can see. This first example says, what is the solution of this system? Use elimination. We have 3x plus 4y equals negative 22, and then we have 5x minus 4y equals 38. If you notice, remember when we're adding or subtracting, we can only combine like terms. So we need to add or subtract the 3x and 5x, add or subtract 4y and negative 4y, and then add or subtract negative 22 and 38. But what we want to happen when we either add or subtract is we want one of the variables, either x or y, to be eliminated or to add or subtract to equal 0. If you look, whether we add or subtract 3x and 5x, we're always going to have an x. It's either going to be 8x or a negative 2x, depending on if we add or subtract, because there are different variables, or there are different numbers in front of our variable. But if you look at positive 4y in the first equation and negative 4y in the second equation, if we add those two values, we're going to get 0. 4y plus negative 4y is 0. Because that is the case, we want to add these two equations combining like terms. The y's are going to be eliminated. So what we're going to do is we're going to take these entire equations and we're going to add them. These are in a great form for us because we can just add straight down. Our x's are on top of our x's, our y's are lined up, and then equals our whole numbers. When we add these, add straight down, 3x plus 5x is 8x. Positive 4y plus negative 4y is 0. They're going to cancel out. And then equals negative 22 plus 38 is 16. Now we have 8x equals 16. Now what we can do is we can divide both sides by 8, and we find that x equals 2. Now, this is where this elimination is similar to substitution. Now that we have x equal 2, we're going to plug in 2 for x into either equation and solve for y. It does not matter which equation you choose to plug 2 in for, you should get the same number. So whichever one looks easier or less confusing to you, go for that one. I chose to plug it into the second equation just because it's equal to a positive 38 instead of a negative 22. So we have 5 times 2, I've plugged in 2, minus 4y equals 38. Well, 5 times 2 is 10, so we have 10 minus 4y equals 38. This is just a two-step equation. We need to get rid of the 10 by subtracting it on both sides, which leaves us with negative 4y equals 28. Divide both sides by negative 4, and you get y equals negative 7. Now we can combine these to make our ordered pair 2, negative 7. Just like with graphing and just like with substitution, when we're using elimination, we still need to plug in our ordered pair into both equations and make sure that it makes a true statement. So, to check our solution, the first equation we're going to plug in 3 times 2 plus 4 times negative 7 equals negative 22. Well, 3 times 2 is 6, plus negative 28 equals negative 22. This is a true statement. 6 plus negative 28 is negative 22. To check the second equation, we're going to plug in and put 5 times 2 minus 4 times negative 7 equals 38. 5 times 2 is 10. You could have thought of that as negative 4 times negative 7 and gotten a positive 28. I went ahead and left it as minus 4 times negative 7, which is negative 28. But notice we're subtracting a negative, which is the same as adding a positive. So 10 plus 28 is 38. So I've checked my answers. I've used elimination. The ordered pair that is a solution to this system is 2, negative 7. The next example, again, we're finding the solution to the system using elimination. In this case, we have 7x plus 2y equals 24, and then we have 8x plus 2y equals 30. Notice again, my x's have a different number in front of them, so I have a constant 7 and 8 in front of my x's. So adding or subtracting is not going to eliminate my x's. But if you look at my y's, both of them are positive 2y. In this case, I need to subtract these two equations, combining like terms. Again, the y's are going to be eliminated. So I'm going to subtract these two equations, combine my like terms. If I have 7x minus 8x, well, 7 minus 8 is negative 1, so I have negative 1x. 2y minus 2y is 0. And then 24 minus 30 is negative 6. You have to be careful here on your integer rules, just like pretty much all year. Just make sure that you're not getting them mixed up. A positive 24 minus 30, you're taking a larger number away from a smaller number, so it's going to be negative. Remember, you are allowed to use calculators if you're in my class from now on. So what I would say is just go ahead and do it on a calculator and make sure that you have the right answer. It doesn't take that long to do 24 minus 30, and it can prevent a wrong answer in the end. Notice we have a negative 1x equal to negative 6. We need to solve and get a positive x. To get a positive x when we have a negative 1x, I'm just going to divide both sides by negative 1. You could multiply by both sides by negative 1 and it would do the same thing. So we have negative 6 divided by negative 1, which is a positive 6. So in this case, we have x equals 6. Now I need to go back and plug in 6 for x into either equation and solve for y. I went ahead and chose to do the first equation. In my opinion, there wasn't really one that was going to be easier than the other. So I just went with the first one. We have 7 times 6 plus 2y equals 24. Well, 7 times 6 is 42. Plus 2y equals 24. Subtract 42 from both sides and you get 2y equals negative 18. Divide both sides by 2 and you get y equals negative 9. So now I have an ordered pair that is a solution to both, that we're going to check and make sure that it's the solution to both of the equations. The ordered pair is 6, negative 9. To check your solution, go ahead and plug in 6 for x and negative 9 for y into both equations. So to check the first one, we have 7 times 6 plus 2 times negative 9, which equals 24. Well, 7 times 6 is 42, plus 2 times negative 9 is negative 18, equals 24. If you plug that into your calculator or do it, that is a correct, a true statement. So I have checked for the first equation. Now I need to go check for the second equation, but to do that I plug in 8 times 6 plus 2 times negative 9 equals 30. Well, 8 times 6 is 48, plus negative 18 is 2 times negative 9 equals 30. We can just think of this as 48 minus 18, which is 30. So it does work for both of the equations that we started with. So 6, negative 9 is an ordered pair that is a solution to the system. The next example, again, we're asked to solve this, find what is the solution of the system, use elimination. In this case, we have negative 2x minus 9y equals negative 25, and we have negative 4x minus 9y equals negative 23. If you notice, again, and sometimes our next example, we will be able to eliminate our x first. But in this case, again, we can eliminate our 9y's first because both of them are 9y's, and actually both of them are negative 9y's. in order to get our negative 9y to eliminate or to equal 0, we need to subtract these two equations, combining like terms. The y's will be eliminated. So we're going to subtract negative 2x minus negative 4x. This is going to be that double negative, so it's actually negative 2x plus 4x, which equals 2x. Integer rules, again, you can use your calculator though. Just plug in negative 2 minus negative 4 and know that the x needs to be come down with it. Negative 9y minus negative 9y, again, subtracting a negative is the same thing as adding a positive, so we would have negative 9y plus 9y, which is 0. They cancel each other out. And then we have negative 25 minus negative 23, which is the same as negative 25 plus 23, which equals negative 2. I need to solve for x by dividing by 2 on both sides of the equation. When I do that, I get x equals negative 1. Just like with the substitution, I now need to plug in negative 1 for x into either of the equations and solve for y. It doesn't matter which one you choose. I went ahead and chose the first one. Again, there wasn't really one that was easier than the other in this case. So we have negative 2 times negative 1 minus 9y equals negative 25. Negative 2 times negative 1 is a positive 2 minus 9y equals 25, negative 25. We need to subtract 2 from both sides, which leaves me with negative 9y equals negative 27. Divide both sides by negative 9 and you get y equals 3. We can combine x equals negative 1 and y equals 3 to form the ordered pair negative 1, 3. Just like with all of my system of equations problems, I need to go ahead and check my answer. To check my answer, I plug in negative 1 for x and 3 for y. So for the first equation, I have negative 2 times negative 1 minus 9 times 3 equals negative 25. Negative 2 times negative 1 is a positive 2 plus a negative 27 equals negative 5, and that is true. So I've checked for the first equation. Go ahead and check for the second equation. Negative 4 times negative 1 is a positive 4, and minus 9 times 3 is 27. 4 minus 27 is negative 23. That also is correct. So I have checked both of my equations, the ordered pair for both of my equations, so my answer is the point negative 1, 3. The last example says, what is the solution of the system? Use elimination. In this case, I have negative 4x minus 2y equals negative 12. And then I also have 4x plus 8y equals negative 24. In this case, I need to add these two equations combining like terms. The x's are going to be eliminated. Negative 4x plus 4x is going to cancel out to give me 0. So the first thing I need to do is negative 4x plus 4x, which cancels out. Negative 2y plus a positive 8y is 6y equals, and then we have a negative 12 plus a negative 24, which equals a negative 36. To solve for y, I need to divide both sides by 6, and when I do that, I get y equals negative 6. Now I need to plug in negative 6 for y in either equation and solve for x. I'm going to choose the second one because there's less negatives to worry about. So I have 4x plus 8 times negative 6 equals negative 24. 8 times negative 6 is negative 48. To get 48, on the other side, I need to add it to both sides, which gives me 4x equals 24. Divide both sides by 4 and you get x equals 6. So the ordered pair in this, the ordered pair that is a solution to this system is 6, negative 6. I still need to check that answer into both of the equations. To do that, I plug them in 6 for x and negative 6 for y, which gives me negative 4 times 6 minus 2 times negative 6 equals negative 12. Negative 4 times 6 is negative 24, minus a negative 12 equals negative 12. Negative 24 minus a negative 12 is the same thing as negative 24 plus 12, which does equal negative 12. Check for the second equation, and you have 4 times 6 plus 8 times negative 6 equals negative 24. 4 times 6 is 24. 8 times negative 6 is negative 48. 24 plus negative 48 is negative 24. That is true. So I have checked that ordered pair 6, -6 is the solution to this system. Today's assignment is on page 398. It's numbers 6 through 20 all.